Okay, everybody, let's roll into information retrieval, research, sources, and tools. If you are on the Canvas website, I do encourage you to go into the module to make sure that you're reviewing all of the material that's associated with the module other than the things that I do mark as optional. And I will typically try to designate certain things as optional, but they may be, in fact, things that'll save you some time and some effort down the road. So we have a lot to cover here, and I hope to do this in a fairly quick period of time. Let's begin by talking about why this is so important. A big job of the design engineer is to really get your arms around an issue, to get your arms around a problem or an opportunity or something that you want to try to solve as part of your engineering work, okay? So there's a lot of stuff out there. We're swimming in data. We have so much raw information that's coming at us. I talked about that in one of the earlier videos. Your job as an engineer is not only to sit down and draw and calculate and do field testing, but it's also to figure out how to put all of that wonderful information to use. So there are a lot of things that we're hoping you learn some skills in 508 and 509. I'm not going to read through all of these, but a lot of this is about retrieving, locating, and then finding effective ways to fully understand, to synthesize. And then at the end, I'll come back every time I talk about this, the ability to retrieve information, because that investment that your company or your employer, it could be an agency or some other employer or consulting company, that investment that they are making in you is in your time. And you don't want to waste time. You always want to be able to go back and retrieve this multitude of sources and literature. Another way to look at this is we are hoping that engineers can help us to take all of this raw data and information that is coming at us so fast and so quickly and make use of it by creating new knowledge and new wisdom. And if you're an engineer, that wisdom plays out through an effective engineering design. If you're a medical professional, if you're a doctor or a nurse, the wisdom plays out through the care and treatment of patients. If you're an attorney, it comes out through helping clients and being able to effectively argue in a trial case, as an example. That's where we take that raw data and that raw information and transform it in ways that are useful. Or another way to look at that is to create the wisdom that you need to be an effective engineer. So in this class, we really have 3 or 4 big items that we want to look at. We want you to locate and get your hands and your minds on and into printed, including digital publications. You will also, when we get to the unit or the module on intellectual property, you'll be looking at patents and past designs. And we will also ask you to talk to people. You'll be talking to people when you do the market analysis, which is part of a future module and a future homework. So let me give you an example here. How might you go about doing this? And you all know how to do internet-based research. You've all probably done papers or other work where you've worked in a library or you've worked on an online database. So I want to kind of give you a formula here. It's not really a formula, but it's maybe a way of thinking about this from an engineering perspective, which may be a little bit different than if you're writing an essay or a technical report for another class. In an engineering project, this is how I would like for you to think about it. I'm going to use an example from 2020. One of our senior design projects was to develop a farm scale hemp decorticator. That's a hard word to say, a hemp decorticator. And the job of a decorticator, it's typically a mechanical device. It's to mechanically separate industrial hemp into its various component fibers. There's lots of different types of fibers. Even in the stem, you have this woody stem of a hemp plant. It might be as big around as your thumb or a little bit bigger than that. And that stem might be 6 or 8 feet tall. It has all different kinds of fibers, and all of those fibers have different uses. So to be able to break the stem apart and separate that hemp is the process that we call decortication. So here's what's interesting. We've heard and we've seen a lot about hemp, industrial hemp in particular, here in Wisconsin in the last 5 years or so. But guess what? This is not a new issue or a new opportunity. If you look at the machine that is in this particular picture, this is actually a hemp. It is a hemp decorticator from the 1800s. This was actually a picture. This was a machine that was built and designed in Germany. So these machines have been around for more than 100 years. We also know that industrial hemp here in the state of Wisconsin is not new either, because back in the early part of the last century, Wisconsin was like one of the top 2 or 3 leading producers of industrial hemp in the entire world. So the idea of doing this background work and this background literature is so that you don't have to start from scratch. A lot of you are going to be assigned to projects, and you might think, whoa, there's probably nobody in the world who's ever thought about this before. But for almost all of our projects, if you dig in and if you do the homework and you do the research, you're going to be able to stand on the shoulders of other people. You're going to be able to take advantage of what they have learned, the mistakes that they have made, the research that they had to do, the field testing. And that's really what we're talking about when we talk about building knowledge, continuing to contribute to the body of knowledge, which is part of the role and part of the work of the design engineer. So if I go back to this problem of hemp decorticators, I know what a lot of your initial searches are going to look like. And by the way, let me just say, I have already done videos on Google Scholar, a really good database, Web of Science, which is available through the University of Wisconsin library system, and also the ASABE technical library, which also, again, if you are coming in through the University of Wisconsin system or UW-Madison, you'll be able to locate and access the ASABE database. So for those specifics, I would ask that you go back and watch those videos. A lot of you are just going to start out and you're going to go onto Google, design hemp corticator, and you're going to come up with a ton of stuff. What I would like to suggest is you begin thinking about some very specific questions. You know, in this case, we want to know what types of designs have been tried in the past. What is hemp decortication? Like, what does that mean? How many acres of hemp need to be decorticated? What's the economic value of that product? And you know, there's a number of questions here. So one of the things that I always suggest you do is to use just regular everyday language like you would use if you were talking to another person, and write down, if you're, and I do this in my work. I usually put aside 60 to 90 minutes at a time, and I try to tackle maybe 4 questions, perhaps 5, but I only try to tackle a few at a time. Otherwise, it becomes overwhelming, and your search can become like it can be a wild set of paths that you can never go back and recreate, and you may or may not find the right information unless you do your search systematically. So I always begin with some questions like what designs have happened with hemp decorticators in the past? So I might search the word design and in parentheses, hemp decorticator. Or in this case, you'll see that I put hemp decort with a star at the end of it. I put that all together in quotation marks because I want to search hemp and then anything that has the word decort. So it could be decortication, decorticators, decorticator. So be thinking strategically about how you can take these questions and convert them into a good search that can be used on Google Scholar or any of those other databases that I've talked about. So industrial hemp process, that could include processes, the word process, the word processing. So you get the picture. Acre, indust, hemp, and then US or Wisconsin. So this is going to find anything related to the number of acres or acreage or acre of industrial hemp. And the way that I've got this structured with US or Wisconsin, it's going to look at things that are connected to either US or Wisconsin, and it is going to group those together. So you get the picture. I'm going to let you look at some other resources at the end of this presentation. What you will find on all of these databases that I have talked about will typically be some things that occur in these different categories. Number 1 will be technical research and reports. And that's where I really want you to focus this first real big homework, where you have to research the size, the scale, the magnitude in the issues associated with this problem. So you're typically going to be looking at things like journal articles, conference papers. It might be a thesis from a graduate student. here at UW, or maybe in another state or another country, who has worked on the issue of hemp decortication. And you might also come across, I would actually really prefer that you come across what we call peer-reviewed journal articles. I'll come back and talk about that in a moment. You also may locate laws, codes, engineering standards. I would ask that you put those aside for the first homework that you work on where you're doing this research. And the other thing that you may find, and you might want to uncheck this box on Google Scholar, is you might find intellectual property. That's why I have you exclude patents, because when you look for patents, that will be in a different homework in the future. Patents are a little bit different than the type of background research that I want you to work on. You might ask the question, because you do hear this a lot in academia. You've got a lot of professors in BSE, and they spend a lot of their time writing what we call peer-reviewed research articles. A peer-reviewed research article is most generally published by a recognized group of people who are experts in the area in which they practice. So in the case of my work, I publish in one of the ASABE journals. Actually, I've published in a couple of different journals with ASABE. I also publish in a journal called the Journal of Agromedicine. So that is run by a group called the National Farm Medicine Center, located actually up in Marshfield, Wisconsin. And when my articles get reviewed, when they get peer reviewed, they are other experts in my field, typically national, or in the case of like the Journal of Agromedicine, they're international experts who have expertise. So that's where they go to. What happens typically if I'm going to prepare a peer-reviewed journal article, I write a manuscript, I write a draft. It's like I'm writing, just like you do in this class, I will write a draft, I'll write a report, I will submit that. When I submit it, I have to go through a kind of a fancy formal process. I usually will have co-authors who are working on this project. So we in academia, we work in teams as well, just like you do in BSE 508 and 509. When I send it in, now I typically will send this in online. An editor will get this and they'll review it and they'll say, okay, does this meet some of the really basic standards, some of the real basic things that we require of all authors for publications who want to publish in our peer-reviewed journal? If so, they will send it out to another group of reviewers. Now, I'm a reviewer on a number of different journals. So when I send my stuff out, it will go to my peers. Those are people like me in this country or in places like Sweden. I've got a person who I've worked with articles with in Sweden, and we both peer review other people's work. And those reviewers typically have a period of time. It's usually about 3 weeks or a month or maybe 5 or 6 weeks to review that article. And we're expected to review it really carefully. And we're expected to be able to fully understand. And the idea of a peer-reviewed article, especially in engineering, is that if you were given the same resources and if you were given all of the facilities and the things that that author had access to, would you be able to recreate that work based on what they explain in their peer-reviewed journal article? So the idea is like full transparency, full documentation of every step, everything that was done, to allow a person to learn from the other person's work and also in the future to maybe be able to recreate that work. What ends up happening then is those reviewers send their reviews back to the editor. The editor oftentimes will look to see if there's any kind of consensus, and then the article gets sent back out to the author. And a lot of times I'll have articles that get sent back that are accepted, but they'll say, yeah, we're going to accept this, but you've got to make a whole boatload of changes in the article. And so I spend some time revising, and then in many cases it goes back, and there's like multiple iterations of back and forth with the reviewers and the editor, and then ultimately the article gets published in a peer-reviewed journal. I'm just going to give you some really quick examples of the difference between peer-reviewed journal articles and technical reports. This is actually, I use this one because this is my first ever peer-reviewed journal article where I was the first author. So this for me was kind of a big deal. I worked on the whole issue of grain combine fires back in the early 1990s, and I developed a fully automatic fire detection and suppression system. So we wanted to detect fires early and then put them out or suppress the fires with a fire extinguishing system that was all fully automatic so that you never had to put a person at risk. So we had like design, we had drawings, we did all kinds of both actual temperature measurements, but we also modeled this so that we could model the temperature rise within a combine's engine compartment. And then ultimately, I think I got 1 or 2 peer-reviewed journal articles from this particular piece of work. And still, if you go back and you look at combine fires and combine fire extinguishment or combine fire losses, you're probably going to find my articles, even though they're a number of years old now. It's still some of the original work that was done in this area. Now, I want to just say this is different. This is different than other layers or other types of technical information. In BSE 508, we really would like for you to look for those peer-reviewed journal articles, but there are also other categories. I'm not going to go through each one of these. These are clickable links. So after I wrote that peer-reviewed article, then it got published like in a technical article by the insurance industry. There's something called extension. Extension is for farmers. We extend the knowledge of the university. So we typically will rewrite these technical articles and we'll make that information really useful for farmers and for end users. Or in some cases, it gets published as like popular press, or in this particular case, a magazine article that was published by an organization called the Farm Progress Publications. Here in Wisconsin, I believe it's called the Wisconsin Agriculturalist. You will probably locate some other types of publications, handbooks, manuals. This could include monographs, textbooks, encyclopedias, reference materials. One of the things you're going to want to really pay attention to when you start to look, especially at textbooks, by the time an author includes material in a textbook, that information is often a few years old. It's probably going to come from technical papers and peer-reviewed journals, and it's going to be the author's own experience, but that experience could be 5 to 10 years old. So make sure if you're leaning heavily on textbook or handbook or manual information that you're taking from the very most recent editions and versions of those particular books or articles or handbooks, whatever it is you might be looking at. We also have a lot of people who bring into BSE 508 and 509 product advertisements and literature. This is okay, but do realize that product literature and product advertisements, there's a bias, right? You've got companies that are wanting to sell their product. And by the way, this could be, this could be a brochure. This could be a hard copy of something that you go to a local dealer and you pick up. It could be something online. So if you go to the online websites of several large manufacturers, Ford Motor Company, John Deere, whatever type of product you're looking at, you're obviously going to find a ton of information on their product, and they may have data, they may have other types of technical information, but I would try to avoid using a large amount of product literature from specific companies. Popular press. So what's popular press? So popular press would be like magazines, Time Magazine, Popular Science, Popular Mechanics. The Wisconsin State Journal would be an example of a popular press article. So these are the types of articles that are available really to anybody who wants to go to a bookstore or subscribe to a magazine. That's what a popular press article is all about. Oftentimes they can have considerable information, but in the case of really good articles, for example, if you have an article about science or medicine in the Washington Post or the New York Times, typically they are going to cite some scientist's work, some scientist or some medical professional's research. So it's actually better for you to go back and trace back the path to find and to actually cite that particular piece when you do this type of work. Let me just wrap up things here with just a few other ideas. I really do like this quote. Abe Lincoln said, give me 6 hours to chop down a tree, and I'll spend the first 4 hours sharpening my axe. I really do believe this. I think in all of the work we do as engineers, whether it's me doing research work at the university or you as a student doing design work, or especially when you get out into the real world and you're designing or you're doing engineering work for a company, make sure you keep your tools sharp. Make sure that you're using the strategies that are going to help you be the most effective and productive and efficient. Because again, I really believe strongly our most precious resource is our time. And the more you can hone those skills and sharpen your skills, the better off you're going to be in terms of using your time wisely. A couple of resources here just to point out to you. Google has got a lot of good information. Here are two that you can click on. The top one is actually a website. It's pretty comprehensive. It's pretty fancy and pretty sophisticated. But I believe that doing a little bit, maybe spending 10 or 15 minutes, can really help you to sharpen your axe when it comes to using Google. If you would prefer to watch a video, this Google Like a Pro is available. And again, both of those are clickable links. Some tips: plan your search. I've already talked about a lot of these other things. Plan your search. Write down in layman's questions or layperson's questions, like in real world human being language, what is it that you're going to try to learn when you're doing the searches, when you're doing your research? And that will take you a long way. Um, some other things, again, these are in that website that I talked about. It's also really important that you pay attention to the date. Some of the articles that I linked, like some of my fire articles, my extension fire article on combine fires is actually from 1994. Now, again, I use that just to show the example from my first ever peer-reviewed paper. But if I got something that was from 1994, I would probably want to be a little bit skeptical and dig a little bit deeper to find more current information. Like I said, just a couple more things to wrap up here. One of the things you may encounter is there are a number of, I'm just going to call them social media or social network sites for scientists and researchers. Academic people tend to be really competitive. We all have these like scores and these factors associated with our reputation and our names. So these websites are all about sharing information, getting your information out there. So it's almost like it's Facebook or Twitter, but it's very specifically aimed at connecting academic people and connecting their research with the real world in hopes of gaining a bigger visibility and a bigger set of recognitions for the work that they do. The one that I'm part of, and I think almost everybody here in BSE is part of, it's called ResearchGate. I'd be a little bit skeptical. A lot of the ResearchGate articles are things that are linked where a scientist may download a paper and make it available through ResearchGate. I would actually suggest, though, that instead you think about using the library resources. Those will typically be there as well. So technical research reports, again, follow information forward and backward. I talked about that a little bit when I did the reviews of Google Scholar, Web of Science, and the ASABE Technical Library. If you find a really, really awesome, fantastic article, you probably are going to want to look to see who subsequent to that publication cited that article. And that might be a way to follow the breadcrumbs forward. And if you want to go backwards in time, you can also look at the references and the resources that that author used. For example, if I write a paper and publish it in 2019, I'm probably going to be citing other people's work from 2019 and prior. So I hope that that's helpful. Some really quick overviews, how to really optimize that search, optimize the research work that you're doing. Again, I just think that it's a super important skill for all engineers to have. Obviously, if you're going to go on and go to grad school and get a master's or a PhD, you have to do this kind of stuff. But I would argue that engineers who are really on top of the game and really understand the products and the markets and the opportunities, they also are people who are going through this same type of activity. With that, I will stop my recording. I'll talk to you soon and look forward to reading your papers that result from all the work you'll be doing and all the research that I look forward to reading.